Okay, so we're going to look at graphs of tangent and cotangent. Okay. We've already done the graphs of sine and cosine. Now we're going to do the graphs for tangent and cotangent. And these are also functions. The original 6 trig graphs are functions. That means they all pass the vertical line test. Okay? And we're going to still look at, let's do a unit circle. Doesn't have to be very big. With the line values. And remember, tangent touches here in all 4 quadrants and goes up or down. Okay, so this represents the line value for tangent. Okay, and then right beside that, we're going to do the graph. And when we do the graphs by hand, we're doing just like Zoom Trig. We're doing the standard labels. So we're going to go every pi over 2. So this would be pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then go on the negative side. So it'd go a negative pi over 2, a negative pi, a negative 3 pi over 2, and negative 2 pi. Okay. And what we're doing is we're going to do a sketch, and then I'm going to do it on the calculator. Okay. So the first thing you kind of have to visualize is if I take and rotate this terminal vector, if I rotate that terminal vector down, what happens to this line value? It gets smaller until if this goes down to 0, okay, then your line value for tangent is at 0. So tangent starts at the origin, just like sine starts at the origin. And as this gets, as your terminal vector gets bigger, okay, this is just going to keep getting bigger, okay, until your terminal vector is at 90 or pi over 2. When it's up here at pi over 2, your tangent is shooting straight up to infinity. Okay, so it's getting bigger, 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 until at pi over 2, and we're actually going to put in what they call an asymptote. Put in a dashed line at pi over 2, and your tangent graph actually is going to approach that line. It won't touch it. It gets closer and closer. Okay, goes to positive infinity. Then when you come over into quadrant 2 with your terminal vector, say I'm over here at 110 degrees or something like that, okay, then your tangent then just switched from down here. So it switches from positive infinity to negative infinity. So it actually comes down here, and then it's gonna get shorter as you come over. I would end up going down here. It's going to get shorter, and as you come over into here, it's going to get shorter. So the tangent line value goes in quadrant 1. Quadrant 1, it goes longer, 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 and shoots to infinity. When you come over into quadrant 2, it's down here at negative infinity, then it just gets shorter, shorter, shorter. Okay? So it's getting till at pi over 2 when, or excuse me, at pi, when you're at 180 degrees or pi, you're back at 0. It's just going to get shorter, shorter, shorter until you're back at 0. Okay? And then it'll get longer, longer, and then we need another asymptote at 3 pi over 2. All those asymptotes are dashed. Okay, and it will get closer and closer. And then if you go into the other quadrant, it's going to shoot back to negative infinity. Okay. At negative pi over 2, there's an asymptote. At negative 3 pi over 2, there's an asymptote. Okay. And you should notice some symmetry there. And there's an arrow on both ends. Okay. So it starts at the origin. Okay, and now I want you to look on your calculator what that looks like. Some calculators will show the asymptotes. Some calculators won't. Mine is of the older operating system, and if I just do tangent, make sure you're in radian mode, and do tangent of x, it's y equals tangent of x, and zoom trig, zoom 7. You should get the same graph, but you have to know on your calculator, like I have to know when I'm graphing this, that this ought to be dashed. That's an asymptote. If you have the new TI 84, whatever, they probably don't show those asymptotes, okay? But these do. So I just have to know, it goes through the origin, here's my pi over 2, that's an asymptote. You ought to look on yours, if yours is a TI 84, you should be able to see. And sometimes those asymptotes appear as spikes, and that means you need to change your window a little bit so it doesn't look like a spike, okay? But the asymptotes ought to be dashed. Okay, so this is the graph for y equals the tangent of x, or theta, whatever they're using for their angle. Okay, now, yep, on this one, when does this graph repeat? You look at this, it's at like, yeah, I look at this and say, okay, it's at 0 and it's going up. When does it at 0 and going up again? Every pi. So the formula for the period on tangent, the period is, instead of 2 pi over the absolute value of b, it's just pi over the absolute value of b. Okay, so this is the formula for the period. Okay, now we want to go back through all 4 of them. Okay, on the amplitude. Amplitude, if you remember when we first defined it, it's the max, like in sine and cosine, it was 1/2 the maximum minus the minimum. Okay, is there a maximum point on this graph? No. So, and the author's going to be tricky on this. I always warn people. Depends on how the author asks it. If the author said, what's the amplitude of this graph? Everybody listen. What's the amplitude of this graph? None. There is no amplitude on tangent. But if the author said, what's the a value of this graph? Is there a number in front of the tangent? Yes. Yep, 1. The absolute value of the number in front. So, yes, there is an a value. That a value controls the vertical stretch or shrink. Okay, so if I put a number in front of that, let's put, you can look at this graph right now on your calculator. Now put a number in front. Let's insert like a 5. Okay? That should have just taken that graph and stretched it out this way. It takes some of the curve out, right? If you want to put in a bigger number, insert like a 225, okay? That really stretched the graph, okay? If I want to put in, let's do a shrink, put in 0.25, okay? That ought to do a vertical squish it together this way. No, if you graph them, it will be with the calculator. The only ones that you have to graph by hand are the original 6. Just like graph this graph. Okay? As soon as I start changing amplitude, period, phase shift, any of that, you have the calculator. I'm mean, but I'm not that mean. Yeah.
So say that's like, you know, say
The scale,
Right.
just under x scale,
Go X scale.
pi divided by 4. Yeah. And they can change the window like 0 to 2 pi or whatever. Okay. Did you see how when I did that 0.25 how they appear as spikes? Okay. I could change the look of that graph by changing my x min and my y min and my y max, and let's say I go -2 to 2. Okay. And it's more back looking the same. Okay. But yes, there is an A value. But the author is going to be very tricky on that. Is there an amplitude? No. Is there an A value? Is there a vertical stretch or shrink? Yes. And it's the absolute value of the number in front. Okay? Okay. Now let's do cotangent. Okay? Okay, so now we want to do y equals the cotangent of x. And I still want to look at you can always go back to the line values, or if you just want to memorize the graphs, that's fine. And we're still going to do our standard labels, every pi over 2. And we will take a day later where we will do good graphs, so you'll have a good copy to keep in your notebook. Okay, and if you think about cotangent, the cotangent line value touches up here right on the circle and goes left or right. Okay, in this case, it would go to the right. Okay. As I extend that terminal vector down, as I bring this down, okay, that cotangent, when I'm at 0 for my terminal, this cotangent shooting out to infinity, okay, to positive infinity. As I start bringing this up, and cotangent starts coming back, starts getting shorter. Okay, so at 0, it's at positive infinity. Okay, so there is actually a asymptote right along the y-axis. Okay, and then your graph starts from positive infinity, and it actually gets shorter till at pi over 2. Up here at pi over 2, it will actually get shorter till at pi over 2 it's a point at 0. Okay, and then it's going to come down. If you go into the other quadrant, as soon as I go into this quadrant, my cotangent starts going negative, so it's going this way till when I'm at if I'm at pi down here, it's shooting out to the negative infinity. Okay, so it's going to go down like this, and there should be an asymptote right at pi. So does cotangent cross the y-axis? No. Okay. At pi over 2 pi, there is another vertical asymptote. At negative pi and negative 2 pi. Okay. And notice the curve, okay, is different than tangent. Okay, and there's an arrow on both ends. What I don't want on this, when you're graphing this, everybody look up here a minute. When you're graphing this, like what I don't want is I don't want this. It's not gonna come through here and then come back away. It's gonna get closer and closer to that. Okay, it won't touch, but the only reason it would touch is because your pencil edged it. Okay. Now, when does this graph repeat? You say, okay, I'm here. Yeah, it's every pi. is if I'm at pi over 2 is 0, when am I at 0 again? 3 pi over 2. So the period of this graph, okay, is also pi divided by the absolute value of b. Sine and cosine was 2 pi over the absolute value of b. Tangent and cotangent, there's no 2 in front. Is there an a value? Is there a number in front of this? Yes. The a value would be 1, the absolute value of the number in front, and that controls the vertical stretch and shrink. Is there an amplitude to this graph? No, there's no amplitude. So if I say on the test, what's the amplitude of this graph? If it's tangent or cotangent, the answer would be no amplitude. If I said what's the a value, or what's the vertical stretch or shrink, it would be 1. Can I do the phase shift, vertical shift? Yes. Okay. Now let's do a graph on the calculator. You don't have cotangent on the calculator, but cotangent is a reciprocal with tangent. You may put this graph in two different ways on your calculator. You can go y equals 1 divided by the tangent of x. And I'm kind of the old school, that's how I learned it. So 1 divided by tangent of x. And we're still in Zoom Trig. And on mine, it's showing the solid lines. If I graphed this on my paper, I'd make sure those asymptotes were dashed. Asymptotes have to be dashed. They can't be solid. No. Okay. Now, that's one way to put that graph in. Okay, go down to y sub 2. Okay. If I put in y sub 2, some of you will like to use the reciprocal key. Okay, and the reciprocal key, you do tangent of x, close the parentheses, and then use the reciprocal key. That's not inverse tangent, it's the x to the negative 1 key, the reciprocal key. So tangent of x, and then the reciprocal key. You should graph it and get the same graph. And the way you can tell it's the same, put the trace key on. Once it's done graphing, put the trace key on, get off the origin. Okay. And then use your up and down arrow. Okay. And if you're getting the same coordinates. Okay. Now, where you have to be careful is when the author gives you an equation like this. In the book, the author might say graph y equals 5 cotangent of x. Okay, if you're putting that in on the calculator, what happens to that 5? Huh? Because that changes. You want to just keep the 5. Yeah, so that's like that, right? So the 5's got to stay up on top. So if I was putting that in on the calculator, okay, let's do that. So you can clear out those. So you would want to make sure the 5's on top, so you got to go 5 divided by the tangent of x. Okay? And then graph that. Okay? And they may ask you for a different window. So this is like the 5 stays up on top, the tangent is on the bottom. And that will give you 5 cotangent of x. Okay? And you can still do the phase shift, the vertical shift. You can put, like I can put, if I did, let's say I did negative 2 tangent x plus pi over 4, plus 9. Yeah, I still have, but if I said on this, is there an amplitude? No. Is there an a value? Yes. It would be the absolute value of the number in front. It would be 2. Phase shift. Pi over 4 to the left. Vertical shift. 9 up. What's the period of that graph? Yeah, it'd be pi over the absolute value of b, and your b value is understood to be a 1 in front of there. Okay? Okay. Enough example? Okay.